Hello, and welcome to this session on Amazon S3 tables, architecture, use cases, and integrations. My name is Lee Keir. I'm a principal solutions architect for S3, and I'll be joined in a bit by Anna Pretty Warade, senior product manager for S3. We are super excited to tell you about the Amazon S3 table feature and how it fits into the data streaming world. So I'll start with the agenda. I'll kick things off by talking for a few minutes about how we see the evolution of data lakes over the last few years and the advent of open table formats. Then I'll give you an introduction into S3 tables, and then Anna Pretty will talk to you about how to stream data into S3 and some best practices. So data warehouses and data lakes have both evolved significantly over time to meet changing data analytics needs. Early data warehouses focused on structured data from transactional systems for business intelligence and reporting. They were built on traditional relational database management systems. And as data grew, new technologies emerged to handle big data in data warehouses, like massively parallel processing, MPP databases, columnar storage, and data compression. Now, early data lakes were inexpensive repositories where organizations could store data in any format. Data governance, metadata, and accessibility were afterthoughts. Now, over the past few years, data lakes have evolved to become more structured, and the term data lakehouse was coined to reflect features like schema on read, master data management, and robust metadata, which improve data discovery and reliable analytics. Real-time streaming processing and machine learning capabilities were added to data lakes to support operational analytics, not just batch processing. Transactional data lakes and data lakehouse architectures were developed to combine the best aspects of data warehouses and data lakes. This enabled transactional and analytics workloads across batch, interactive, and real-time requirements. Customer requirements have also evolved over the years. Customers want a single platform for analytics, transactional, and GenAI workloads, which provide asset compliance, can deliver integrated governance, are scalable, and open. Customers are looking for real-time analytics and insights, for compute resources that can scale elastically based on demand, and the ability to handle a variety of data sources and formats. The abundance of raw, granular data in a data lake enables more sophisticated analytics like machine learning and AI, which would not be possible in a traditional warehouse. This diagram shows the properties of a data warehouse on the left and a traditional data lake on the right. In the middle is what you get from a transactional data lake, also known as schema on read architectures. So a transactional data lake and the schema on read architecture allows analysts, data scientists to quickly explore new data sets without lengthy upfront modeling as required by traditional data warehouses. This drives faster insights. Data lakes have a flexible schema which allows for storing raw, unstructured data. The schema is applied at query time rather than ingestion. This is more adaptable compared to rigid schemas of data warehouses. Transactional data lakes offer several benefits, including advanced analytics readiness. Transactional data lakes make it simpler to apply techniques like ML and AI to both structured and unstructured data at scale. Lower cost. Storing multiple raw copies of data for different analytics use cases is inefficient. A transactional data lake provides one source of truth for both batch and real-time processing. It's easy to scale. Cloud-based transactional data lakes can easily scale storage and compute as the data volume grows, with no overhead of managing the infrastructure. You get real-time analytics. Ingesting and analyzing streaming data is much easier in a transactional data lake than with most data warehouse systems. This enables real-time reporting and predictions. And finally, as a single integrated platform, a transactional data lake avoids siloed data warehouses, data marts, and data lakes. This consolidated approach enables governance, reduces duplication, and improves data quality. In summary, transactional data lakes provide a versatile, scalable, and cost-effective data analytics foundation for the modern data-driven enterprise. They accommodate diverse data and workloads while simplifying data management. Now, 3 open table formats are Apache Iceberg, Apache Hudi, and Delta Lake. Now, AWS supports all 3 of these open table formats. Apache Iceberg is an open source transactional data lake high performance format for our large analytics tables. Iceberg brings the reliability and simplicity of SQL tables to big data. Apache Hudi, an open source transactional data lake framework that greatly simplifies incremental data processing and data pipeline development. And Delta Lake is an open source storage framework that enables building of transactional data lakes with compute engines like Spark, Flink, Trino, etc., and also APIs. To overcome the challenges of traditional data lakes, open table formats provide database-like capabilities while still storing storage on cost-effective systems like Amazon S3. These features include asset transactions, allowing a write to completely succeed or be rolled back in its entirety. Record level operations, allowing for single rows to be inserted, updated, or deleted. It has scalable indexing or metadata to improve performance, in addition to data lake techniques like partitioning. It allows for concurrency control, allowing multiple processes to read and write the same data at the same time. Schema evolution, allowing for columns of a table to be added or modified over the life of the table, and time travel, enabling you to query data as a point in time in the past. Very cool feature. Now, AWS remains committed to delivering support for all 3 open table formats, Apache Iceberg, Apache Hudi, and Delta Lake, to meet our customers where they are. Customers are increasingly asking for Apache Iceberg support due to its robust capabilities, vibrant open source community, and broad support across the industry. Therefore, AWS is prioritizing building differentiated features for Apache Iceberg based on customer need. If a customer doesn't already have an OTF they prefer, we advise customers to adopt Apache Iceberg for getting the best experience with OTFs on AWS. And to help customers manage their Iceberg tables, we introduced S3 Tables at reInvent 2024. S3 Tables is purpose-built to store tabular data and provide fully managed Apache Iceberg tables in S3. So let's get to the details. Before we dive into the benefits, let's touch upon why S3 Tables. We have many customers who have already adopted self-managed Iceberg where the data lives on S3. But managing Iceberg tables independently presents 3 key challenges: performance, security, and cost optimization. As more applications work with shared data sets, the increased traffic puts pressure on performance. While Iceberg enables concurrent access, maintaining optimal performance requires regular maintenance like compaction. Compaction demands additional resources and management overhead. I'll cover the details of compaction in the next slides. Security also becomes more complex when trying to enforce consistent access policies across different query engines. Managing permissions based on physical data and metadata layout is cumbersome and prone to errors, and creating fine-grained access becomes challenging. Storage management is particularly challenging due to Iceberg's snapshot architecture. For every write, Iceberg creates snapshots, and they accumulate over time. Organizations must invest in compute resources and teams to manage snapshot cleanup and remove unused files. This adds operational complexity and cost. With S3 Tables, which is a fully managed solution, we provide optimized performance, simpler security controls, and automatic storage cost optimization. With S3 tables, you get up to 10 times the transactions per second, or TPS, out of the box when compared to prefixes in general purpose buckets. This combined with automatic compaction that runs in the background to consolidate your data files means you can get up to 3 times faster query performance with S3 tables. Okay, let's unpack this. With table buckets, you can expect up to 10 times the TPS as compared to general purpose buckets. So that's 55,000 reads or 35,000 writes right out of the box as soon as you create your tables. And it continues to scale beyond that as your workload scales up, similar to what you see with general purpose buckets. Now, the higher baseline TPS from table buckets can help you to easily stream data into your tables quickly as soon as they're created. You don't have to wait until S3 scales up like you sometimes do for general purpose buckets. So let's take a look at compaction. With Iceberg tables, as you continue to evolve your data sets by updating or removing records over time, you're going to accumulate all those changes as additional files in your table. As your table scales, your applications now need to go through all of those individual files when they're querying that data, which can add up and make your queries run slowly. Now, Iceberg provides ways to optimize this through compaction, which consolidates smaller data files into larger ones. This reduces the number of requests that applications need to make when going through the data files during a query, and therefore makes those queries faster. Now, to run compaction, customers previously needed to spin up compute resources and manually run compaction operations on their data files. This increased the amount of effort and time to keep your data sets optimized. With S3 tables, you now have compaction running periodically in the background that automatically consolidates smaller Parquet data files into larger ones. This means your application needs to make fewer requests when querying the data, making your queries up to 3 times faster. So over time, as you're updating these data sets, you are also generating new snapshots that reference the new data files. But you also have older snapshots of the same data, which you probably don't need to keep around forever. So you want to age out those older snapshots as well as remove any objects that are uniquely referenced by it. To do these table maintenance tasks today, you may need to deploy additional compute resources and routinely run procedures to clean out your tables and garbage collect any unreferenced objects. Now with S3 tables, you can completely rely on S3 to take care of such tasks for you. S3 tables automatically runs periodic maintenance operations to expire older snapshots and garbage collect any unreferenced files in your table. With Apache Iceberg on general purpose buckets, in order to govern access to your tables, you had to craft policies, which required you to know the physical location of your data and metadata files in your storage. You may have also had to separately govern read and write operations on your objects and commit operations on your tables. Now with S3 tables, you can directly apply resource policies on the tables themselves, allowing you to govern which applications have the right level of access to your tables. This is where namespaces come in handy. With table buckets, you can create namespaces as a way to logically group different tables together. So think of dev, staging, production tables grouped into their own separate namespaces with separate permissions on who gets access to each of them. Okay, now Anna Prutti is going to talk to you about streaming data on Amazon S3 tables.
Thanks, Lee. Now that we have heard a deep dive on Amazon S3 tables and how they provide a strong foundation for managing large-scale structured data sets in an open format, let's switch some gears. S3 tables and more broadly, Apache Iceberg table format is extremely versatile. You can use it to store data from batch workloads like batch ETL to CDC to machine learning and compliance use cases. Considering today's theme, I want to zoom in on one specific use case that is streaming data directly into S3 tables. Today, more and more organizations are shifting away from traditional daily or hourly batch jobs to streaming first architectures, where data is ingested continuously to enable decisions and real-time insights. On S3, we find customers streaming clickstream data to track users' behaviors on the website and apps in real time, enabling them to personalize experiences and recommendations. Others using machine learning on transactional data streams for fraud detection, catching anomalies the moment they occur, and prevent them from having accidental losses. In the IoT space, we are seeing customers stream telemetry from millions of devices across industries like manufacturing and energy, where real time monitoring can actually improve the uptime and efficiency. And then there's operational analytics, where teams in logistics, healthcare, and airlines rely on continuous data flows to make informed split-second decisions. All of these use cases demand continuous ingestion, low latency access, and a storage layer that's structured and queryable from the day one. So let's take a look at how this actually happens. To power these use cases, customers are using a variety of streaming engines. Here we have highlighted some of the popular ones we see in the field. Like there's Amazon Data Firehose, which is a fully managed solution from AWS for direct ingestion right into S3. StreamNative's Ursa engine, which offers tight integration with Apache Pulsar. And then there are these open source engines like Kafka, Flink, and Spark for rich event processing and transformations. These engines take care of filtering, enriching, and aggregating data in motion before writing it directly into S3 tables in Apache Iceberg format. Now, once the data lands into this bucket in S3 tables in a table bucket, it's not just sitting there in raw files. It's organized into Iceberg data tables that are immediately queryable. So now you can access the data using AWS analytical engines like Athena, Redshift, EMR, SageMaker Studio, and many other open source and third-party engines. We've listed some, but these are just a few. It's not limited list. This means there's no need to copy data between the systems. Your structured, fresh streaming data is available everywhere, open, performant, and cost-efficient at scale. Now that we've seen what's possible with streaming into S3 tables, let's look at a few best practices for optimizing the performance and cost when using Iceberg tables for streaming workloads. Streaming data into Iceberg tables on S3 opens the door to scalable, real-time analytics. But to get the best performance, reliability, and cost efficiency, it's important to follow a few best practices. We'll start with concepts like partitioning and sorting. Always start with smart partitioning, which by that I mean is by low cardinality columns, like for example, region, event type, and then sort by high cardinality columns, like timestamp down to hour or even seconds. This helps optimizing both streaming writes and downstream query performance. Choose the correct write strategy for your workload. Especially for streaming and very upsert heavy pipelines, use merge on read and always aim to write into large Parquet or Avro files. For example, you can set the write path for the files to be about 100 MB. Is a good target to begin with. When using Spark, you can also tune options like write Spark fanout enable true to parallelize multiple writes at the same time, and also avoid shuffle when you're trying to write the data using write distribution mode set to none. What are some other things that you could do? So in like managing your data, in streaming workloads create high volume of small files, especially when ingesting real time with multiple parallel writers. Over time, this can impact both query performance and cost, especially in Iceberg, where metadata needs to track each individual file. I know Lee covered a part of it already before, and this might be a repeat. However, like when you regularly run compaction jobs, Iceberg supports strategies like bin pack, sorting, and z-ordering to consolidate these small files into fewer larger ones. This means this overall improves the scan efficiency and helps query engines skip irrelevant data. Another key practice in data management is to manage your snapshots properly. Since Iceberg tracks every table change as a snapshot, and most cases are not going to require all the snapshots for the time travel use cases. Hence, expire those snapshots to clean up the older versions you no longer need. Similarly, for the orphan files, these are the leftover data files from failed or aborted writes. They are not referenced in a metadata, but still sit in your S3 table bucket and accrue cost. Use the remove orphan files action to periodically clean them safely. These table maintenance steps are key to keeping streaming Iceberg tables fast, clean, and cost effective. Next, for the high volume streaming ingestion, especially when you have parallel writers, you'll want to tune for concurrent commits and write stability. If not configured, it can lead to commit contention retries and latency spikes. You can start by increasing parallelism with the settings such as like worker num threads, which controls how many threads can process the data and write files concurrently. You can also improve reliability with commit retry tuning. Configure commit retry num retries and minimum wait milliseconds to ensure transient failures don't cause job failures. Together, all these settings ensure your streaming jobs are resilient, scalable, and able to keep up with real-time demand without bottlenecks at the metadata layer. And finally, use S3 tables to benefit from 10x higher TPS when writing to storage and simplify table management at scale. So whether you're managing billions of files or thousands of writes per second, these best practices will help you maintain a healthy, high-performance Iceberg tables over time. That's all for today. Up here, we have few resources for you to refer. The first link takes you to a documentation hub of S3 tables. You can learn more about S3 tables, how it works, the documentation on getting started. The second is a link to a detailed blog post that walks you through how you could use StreamNative's Ursa engine with S3 tables. And the final one is a hands-on workshop that shows you how to stream data into S3 tables. And then finally, thank you so much for taking time. Feel free to check out the resources we shared and reach out if you would like to learn more or try it out yourself. Thank you.
Awesome. That was great content there, Anu and Lee. Phenomenal. I thoroughly enjoyed the session. So thanks for doing that. Let me see if there are any questions in Q&A channel. We have a bunch of people attending this today. The session is quite popular. So folks, if there are any questions on S3 tables functionality for whatever you heard today in general, I think, please bring it up. This would be a good opportunity to ask any questions. Also, actually, while people are bringing up questions, anything you want to add to what you covered today, is going to be helpful. I think you shared some information about the blogs, which is really great as well. So I think you spoke about various types of integrations. I think ever since you launched this functionality last December, I guess, I think after that also, you all announced one more blog with a bunch of new updates. So a lot of exciting stuff happening there. So anything you want to continue to add while our folks, we'll give them a little bit more time to kind of post questions.
Yeah, absolutely. Let's talk a little bit about the workshop that we linked we have there. So that's going to be available for about the next 48 hours. This is an absolutely free workshop. If you click that link, and maybe we should put that link back into the chat here in a second, you will be able to go through the workshop. This workshop shows streaming to S3 tables. Now this uses an AWS service. It doesn't do stream native, but you can, imply from what you'll do in that workshop that how it would work for stream native. So let me go ahead and put that link into the chat here. I think it's that one right there. Yes. And so that gives you an access code. You can just click that link and get in there. And you can do that for up to the next 48 hours. So you'll have time to run through it at your own pace.
Thanks, Lee, for covering that. I also want to share that, yeah, Kundan, you mentioned since the launch, we have had many more launches, and in fact, we'll continue to add more and more features to this product. I'm just sharing a link to a blog that outlines all the different new launches since our reInvent initial announcement. So happy to take any questions on any of these features as well.
Absolutely. Yeah, let me see. I think there is one question. A couple of questions are coming up now. All right. So the first one is automatic table maintenance is great. How does it compare with other managed Iceberg table offering?
Yeah, so we follow the Iceberg open source Iceberg compaction methods that are available. So today S3 tables offer the default compaction method, which is the bin pack method that's available right now. And then there is other methods like Z order and sorting as well, which are not available yet onto S3 tables. So S3 tables offers a very basic one bin pack algorithm. The other managed providers, I think there are a variety of providers, as you know, in the ecosystem. Some of them might offer the same as what Iceberg offers, or some of them may also have their proprietary optimizing or compaction algorithms. I think it's specific to the provider that's providing that.
Got it. I think within Amazon, within AWS, basically S3 tables is sort of the primary way to, read and write Iceberg tables within your specialized, I would say, store, right, bucket. Is there any other offering within AWS which does something similar? Probably not directly, right? There is integration with the glue, but I think I was trying to see if this question was comparing to other offerings within AWS or probably outside, maybe referring outside, I guess.
Yeah.
Got
I
it.
mean,
Got it.
within the AWS, it's the same bin pack algorithm.
Got it. Okay. So we'll move on to the next question. What tools do you use for table maintenance, compaction, Spark, or custom tools?
It's our internal implementation detail. So it's a combination of Spark and our custom implementation tools, I believe.
Got it. Okay. There's one more right there. Iceberg has its REST catalog and AWS has Glue catalog. What are the plans for these two catalogs?
As of couple of weeks ago, I think earlier this year, Glue catalog also supports Iceberg REST, Iceberg's REST catalog specifications. So you can use that as well to connect to AWS Glue data catalog.
Cool. And I think just on that note, I remember when we were doing this blog together, we validated our native integration, like, from Stream Native and Amazon S3 tables. I think there were certain improvements which were getting planned between S3 tables being able to natively, like, either integrate with Glue Catalog, and anything you want to share if that's still in the
Yeah.
works, or is it already there?
No, you're totally right. So when we were working on this integration with Streaming, you were one of the very early partners with us. So thank you for that. But that time, integration with AWS Dude catalog wasn't available at GA. It was under preview. So when we went live with our integration with Stream Native, it was also the same time we went live GA for our integration with AWS Glue Data Catalog. That's like the SageMaker Lakehouse. So both the things were very in parallel about the same
I
time.
see. That's awesome. That's great. That makes it much more easier as well to have a broader, story around how your services are talking to each other anyways. One more question there. What is the plan to support Iceberg version 3?
Yeah, we are very excited. We are learning about the new updates that there was a summit, so there was much excitement in the community as well as internally about V3 format. We are right now assessing the changes, and we should have some plans soon. We don't have any timelines to share at the moment on that though.
Cool. Sounds great. I think those are the only questions I see so far. I'll give another 10 seconds or so to see if there are more questions. But I think this has been great content, and definitely we'll stay tuned on all the great work which you guys are doing, and keep an eye on how we can work together, the community can work together also with AWS to offer, or build these native integrations with S3 tables. So,
Yeah. Thank you for having.
awesome. I
Great.
don't
Thanks
see
for having
any
us.
other questions. So great. Thank you again for the awesome content. We'll stay in touch. Again, for the folks who watch this session, the recording of the session will be shared after the event. So we'll do that, and then you can go through that in length. I know there was a lot of information there from Anu and Lee, so I think you can go back and watch that again. So awesome. Thanks again for your time and great content.
Great. Thanks for having us.
Thank you.
Thank you. Bye-bye.